So let's go ahead and jump into this. So on our warm up, AB is congruent to what? Side AB is congruent to what?
DC.
Side DC. These two are congruent since it's a parallelogram. Okay, AD is congruent to what?
BC.
To BC. These two are congruent. And then angle D is congruent to what?
B.
To angle B, because those are opposite angles. Good. All right, so what is the sum of the interior angles of ABCD? So how many sides does it have? 4. So for the interior, remember you do n minus 2 times 180, which, I mean, this one you should know, but it's 360. So if you add up all 4 interior angles, add up to 360. Now, what is the sum of the exterior angles? Remember, it doesn't matter what shape it is. The exterior angles always add up to 360. Does not matter how many sides, it's always 360.
90.
All right, yep. And so on this last one, if this were a regular quadrilateral, what does regular mean again? What does it mean if it's like a regular quadrilateral or regular polygon in general? What does regular mean?
It is normal.
Well, not that it's normal.
It
Everything's
looks like
congruent.
that.
Well, it doesn't look like this, honestly.
It's a rectangle.
Does it look like a square?
It's like a square. Regular just means all the sides are the same length and all the angles are the same.
Oh.
Okay? So that's what it means. So if all of these angles were the same measurement up here, how big would each angle be?
90.
It'd be 90 degrees. Yep. Okay, so the stuff we're talking about today is the same stuff that we talked about on Thursday and Friday. It's just that we're going to be working backwards.
That makes no sense.
So on Thursday and Friday, what we were doing is like, okay, this is a parallelogram. And since it's a parallelogram, then these properties are true. What we're going to do today is we're going to look at it and see, okay, does it have these properties? And if it has these specific properties, then I know it's a parallelogram. So we're doing the same thing, it's just working backwards. All right. So on this first one right here, and let's go ahead and number it because we're going to use these numbers as we go through what we're talking about today. So the first one here, somebody read this statement right here for me.
If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
Okay, good. So like what it's showing here, if both pair of opposite sides are congruent, then you know it's a quadrilateral. So I want you to write that next here to number 1 is opposite sides are congruent. Okay? So if you look at some quadrilateral, it's got 4 sides, and both pair of opposite sides are congruent, you know it's a parallelogram. These are ways for us to test to see if it is a parallelogram. Okay? Second one. Somebody read this statement. Somebody different. Read this statement right here.
If both pairs of opposite angles of a quadrilateral are congruent, then quadrilateral is a parallelogram.
Okay, good. So on this second one, if opposite angles are congruent, then we know it's a parallelogram. So number 1 is opposite sides are congruent. Number 2 is opposite angles are congruent. All right. Third one. Okay, somebody different now. Read this one.
If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallel.
Okay, good. So again, this is one of those properties we talked about last week. You can see how these two diagonals cut each other exactly in half. So this is another way for us to know it's a parallelogram, is that the diagonals bisect each other. Okay, the diagonals bisect each other. That's a third way for us to know if a 4-sided shape is a parallelogram. Now the fourth one, well, the first 3 we talked about all of those last week. This fourth one we really didn't talk about, so it's just another way to test for a parallelogram. All right, somebody different. Read this last statement right here.
If one side of
opposite side of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram.
Okay, good. So like what the picture shows right here. So you can see how this side, these two sides are parallel, and also those same sides are congruent to each other, okay? So on this fourth one, all right, one pair of sides is both parallel and congruent. One pair of sides is both one pair of sides is both parallel and congruent. Okay, so these are the 4 ways for us to test to see if something is a parallelogram. So on this first one, can I say that quadrilateral is a parallelogram?
Yeah.
Yes, I can. Okay, it is. Now the question is which one of these 1, 2, 3, or 4 shows that or talks about that?
2. No.
No. One.
It's number 1, because number 2 is talking about what?
Angle.
The angles. This down here is talking about the sides. So this is based off of reason number 1 from up top up there. This side is congruent to this side, and this side is congruent to this side. So yes, that's a parallelogram because opposite sides are congruent. Okay? This one, can I say that this one is a parallelogram?
Yeah.
Yep. Because of which reason up here?
4.
Because number 4, you have this pair of sides that are parallel, and you can also see that they're congruent to each other. So based off of number 4. All right. So on this, first of all, let's mark it. It says AD is congruent to BC, and AB is congruent to DC. Now, before I do anything else, is that a parallelogram if that's true?
Yeah.
Yes, because of which one up there?
1.
Because of number 1 again. Now, I want to know which of these will always be true regardless of where the jack is at. How far up or down it is. Is angle A always going to be congruent to angle B? Is this angle right here always going to be congruent to this angle right here?
Wait, what angle?
What other angle?
Oh, this is not, sorry, it's not catching up. Yeah.
No. Wait, yeah.
Yep.
No.
I don't know why this is like totally stopped.
It's just saying stuff.
Yeah.
Okay, so right here, angle A and angle B, or angle A and angle B always going to be congruent?
Yes.
No.
Nope. And there we go.
Dang,
Little America.
Okay, there we go. I think it's back on now. Okay, so is angle A and angle B always going to be congruent?
No.
No. Remember we talked about this. What do we know about angle A and B? What will always be true of these two in a parallelogram? They're going to add up to 180. That's right. So this one is not true always. Okay? Okay, answer choice B right here says that angle A and angle C are always going to be congruent.
Yes.
It's slowing me.
Is it doing it again? Yep. Okay, so this is saying angle A and angle C, are these always going to be congruent?
Yes.
Yeah.
And the answer to that one is yes. Opposite angles in a parallelogram are congruent. That's the one. AB and BC, not always congruent, and A and C won't always add up to 180. All right. So on this one it says, find X and Y so that the quadrilateral is a parallelogram. So for this to be a parallelogram, what do I know about these two sides right here? What has to be true? They have to be congruent. And then same thing here. These two sides have to be congruent to each other. So I need to find the value of X and Y that makes that true. So I'm just going to set them equal to find what the value of X needs to be. So let's start off with the X. So we're going to have 4X minus 1 needs to equal 3 times X plus 2 for this to be a parallelogram. All right, so we have 4X minus 1 on this side. And what are we going to have on the right-hand side?
3x.
3x plus 2.
3x plus 6.
3X plus 6. Remember, you got to distribute that 3. It's got to go here. It's got to go here.
I forgot about that one. My bad.
All right, so now we're going to solve for X. Subtract 3X from both sides. That gives me 1x or just x over here. So x minus 1, this zeroes out, equals 6. So x needs to equal 7. Sorry. All right. Now, same thing's got to be true over here. The y, these two sides have to be equal. So I'm going to set those equal and find what value of y makes that work. So the 3 times y plus 1 needs to equal 4y minus 2. So what do I have on the left-hand side there after I distribute?
What was the question?
What's this going to be after I distribute?
3y plus 3.
3y plus 3 needs to equal 4y minus 2. Get the y's together, subtract 3y from both sides. This zeroes out. 3 equals y minus 2, add 2. And the y needs to equal 5. Okay, then on the next one, same thing. Those two sides would have to be congruent. I would just set them equal to find the value of m. So I'm not gonna work that one out. Okay, so this last deal here, these are ways for us to prove that a quadrilateral is a parallelogram. So there's several different ways. Okay, one way is to show that both pair of opposite sides are parallel. Okay, another one is to show that both pair of opposite sides are congruent. Number 3 is show that both pair of opposite angles are congruent. Next one is show that the diagonals bisect each other, or you could show that a pair of opposite sides are both parallel and congruent. So there's a bunch of ways, but what we're going to do is do it this way right here. That's the way we're going to use to prove it. Just the definition of a parallelogram. See if both pair of opposite sides are parallel. So this is going to take us back several months ago. How do I know if two lines are parallel?
The little arrow thingy.
Okay, well, if you have that drawn on there, that's fine. But if you don't have that, if you're trying to see are two lines parallel, how do you know? Okay, they're never going to cross. That's true. So how do I know that they never cross?
You draw a really long line with the pencil to see if they cross.
No. How can we tell if two lines are parallel?
Solve for x. I don't think any of us remember.
They're the same.
Okay, they're the same what? They have the same what? Not the same length. Okay, so if these two lines are parallel.
Same direction.
Okay, you're getting closer, same direction. So these two lines right here, I want to know, are these two lines parallel? How would I know if they're parallel?
They look like 11.
This goes back to like some algebra stuff. It goes back to algebra.
Oh, you remember what I
Those
used
little
to?
marks.
So they have opposite.
Okay, you're on the right track now. You're thinking of perpendicular, what you're starting on, but it's in that same idea, so you're in the right place. How do I know if two lines are parallel?
That little mark.
If they're
That little
perpendicular,
mark.
you have the same X.
Okay, you're getting real close.
Can you just tell us now?
Nope. Somebody's gonna get it. Nathaniel's on the right track. I can tell his wheels are spinning. He's about to get it.
Come on, Patrick.
The only thing Will's is spinning is his eyes.
How do you know if two lines are parallel?
Okay, Google.
Again, this is algebra stuff right here.
There's so many, I don't even know what I ate yesterday.
Oh, is it like the formula? No,
Okay, yeah, formula. Formula for what?
They have the same rise over run.
That's it. What do we call rise over run? There you go. Thank you.
Slope intercept.
They have the same slope.
I remember now.
Ah, now everybody remembers same slope.
I'll be honest.
Good. Now, slope is rise over run. Remember that? Rise over run. So the top number in your slope is going to tell you how far up or down you go. The bottom number is going to tell you how far to the right you go.
And we wasted like 10 minutes trying to figure that out.
Well, you finally got it. Everybody worked together and finally got it. That's good. Okay, so remember that's the slope. The top number tells you how far up or down. Bottom number tells you how far to the right. Okay. So let's see if this is a parallelogram. So let's find the slope of this side right here of TQ. Okay, so for TQ.
So don't you go to left one and down?
4/1.
Okay, so remember the top number is your rise. Okay, you have rise over run. So
1/4.
Yeah, one
no, you're right in the first place. I just want to get this down. So you go up 1, 2, 3, 4,
over one.
and then you go over 1. So the slope of that is 4/1.
Or just 4, right?
Or just 4. Yeah, that's fine. Okay, and so now I want to check the slope of this side that looks like it's parallel to. So SR, what's the slope of SR? It's up 4/1. Same thing, right? So are these two sides right here parallel to each other? Yes, they have the same slope. Okay, so now I can put these little arrowheads on here. Oops. I can say that this side is parallel to this side because of this right here. They have the same slope. Now, it's not good enough just to know if those two, I have to know the other ones also. So let's check those. Okay, so for QR, this side right here,
-2/4. Or
Good.
-1/2.
so you go down 2, okay? So down 2 is the top number, and then you go over 1, 2, 3, 4. So you go down 2/4. And yeah, we could simplify that to -1/2 if you wanted. I'm just going to leave it like that. And then for the other side over here, TS, what's the slope of TS?
2/4.
Down 1, 2. So it's down 2 and then over 1, 2, 3, 4. So are these two parallel to each other?
Yes.
Yep. Okay. So this side is parallel to this side. And that right there proves that that's a parallelogram. Okay? Based off of this one right up here. Both pair of opposite sides are parallel. It's the definition of it. So basically it's asking, is this a parallelogram, yes or no? Yes, it is. All right, next, I want you to plot those 4 points, E, F, G, and H, from this right here. Plot those 4 points, E, F, G, and H.
Oh man, how are we doing this? Like,
So -2, 2 is E, 2, 0 is F, 1, -5, 1, 2, 3, 4, 5 is G, and H is -1, 2, 3, 1, 2.
oh yeah, now we dropped a little line. I think I messed up. Never mind. No, I didn't. I actually got it right.
Okay, does this look like a parallelogram?
Not really.
No, it looks
Kind of, but
No, it doesn't.
looks
It
like
looks like it's a little bit off to me. So let's just, to me it looks like this side and this side are off a little bit. So let's just check and see if they don't have the same slope. That means they're not parallel. It's not a parallelogram. Okay, so let's start off with EF right here.
-2/3.
Okay,
Alright, never mind.
so what's the slope of EF?
-2/4.
Down 1, 2, and then over 1, 2, 3, 4. So it's -2/4. And for this to be a parallelogram, HG would have to be parallel to it. So for HG, what's the slope?
-2/3.
1, 2, 3. 1, 2, 3, 4. So this is down 3/4.
Dang.
So are these two parallel to each other?
I messed that up pretty bad.
Okay, so that means these two sides are not parallel. No, this is not a parallelogram.